Yeah? 1 and 2 is correct because that's where the y values are above the x-axis. Okay? For the cosine, it's 1 and 4. With me so far?
Mm-hmm.
All right. What about for the tangent? No. 1 and 3. Because the tangent is the y divided by the x, which means they either both have to be positive or they both have to be negative. So keep that in mind. Take a look at this next problem. This next problem says that we have a tangent which has a square root of 3, which I know that if I was going to write it as a fraction, I would have actually written it as the square root of 3 over 1. But I know that this tangent could be in quadrant 1 or it could be in quadrant 3. So I'm going to draw 2 triangles. I'm going to draw a triangle in quadrant 1. But I'm also going to draw a triangle in quadrant 3. These 2 triangles are representing a tangent which will have a square root of 3. Because we talked about the tangent is positive in those 2 quadrants. Let's first of all focus on the orange triangle, the one in quadrant 1. Tangent is the opposite over the adjacent. If I try to find the other side, I'll use the Pythagorean theorem. So 1 squared is 1, plus square root of 3 squared is 3, 1 plus 3 is 4. Take the square root, and I get that this side is a 2. If I use these same numbers, but draw it in the purple triangle, which is in quadrant 3, I know that both parts of the coordinate have to be negative. So really, the opposite side is the square root of 3, but I know it's negative. How do I know? Because I went down underneath the x-axis for the y value. And I went to the left for the x value, so I know that this value is negative 1. And the hypotenuse is never negative, so that's just a positive 2. Now when I answer all of these questions that they ask me about, the trig ratios, I'm going to use both the purple and the orange answers. So that's kind of important. So let's look at our triangles and find each of these things. In the orange triangle, what is the sine of theta? Very good, square root of 3 over 2 in the orange triangle. In the purple triangle, does that change? No. Yes, it does. Because it's negative. So the other possibility is that it's negative root 3 over 2. So there are 2 answers to this problem. The cosine in the orange triangle is the adjacent over the hypotenuse, or in other words, 1/2. And in the purple triangle, that's going to change because it's in quadrant 3 and it's negative 1/2. And now what I know is we already have the tangent because they gave it to us right over here. So to find all the other answers, all I have to do is flip all the ones I've got so far. Notice how the tangent doesn't matter which quadrant it's in, it's positive, period. So that means the same is true for my cotangent. My cotangent is going to be positive no matter what. So I'm just going to write down 1 over radical 3. I wouldn't leave it like that on a test, would I? No. The secant has 2 answers because it's the reciprocal of the cosine. So one answer would be the orange answer. Flip that and I get 2. One would be the purple answer. I flip that and I get negative 2. Because the secant and the cosine are reciprocals. Or as Tristan asked earlier, can we do plus or minus 2? For sure we could. And then the cosecant is the reciprocal of the cosine. So in the purple, that would be negative 2 over radical 3, which of course we would simplify by getting the radical out of the denominator. And in the orange triangle, that would be 2 over radical 3, and we would also as well simplify that. So the big idea here is to understand that from our unit circle, depending on which quadrant you're in, you may have different answers. So if they tell you something like the tangent, the sine, and the cosine is a certain value, it's that value in 2 quadrants. Be ready to find both answers. In the next example, A and B, they just want to show you that whenever they use the word identity, that means equal. Like 5 $1 bills are identical to a $5 bill in value. That kind of thing. So let me show you what's going on here. Whenever they talk about trig identities, the first thing I think about is transfer, if you can, if there are no squares, into sines and cosines. Whenever possible. So if you don't see any squares, go to sine and cosine. So in this first example, what I notice is that I have a cosecant, I have a tangent, and I have a secant. If I talk about the cosecant, and I want to talk about sines and cosines, that cosecant is really 1 over the sine, because it's a reciprocal of that. If I talk about the tangent in sines and cosines is the same thing as the sine over the cosine. And if I talk about the secant is the same in sines and cosines as 1 over cosine. As you look at the left-hand side of the equation, hopefully you will see that the signs reduce. 1 on the top, 1 on the bottom. So sine divided by sine is 1. So I end up with 1 over the cosine equals 1 over the cosine, and I've proved that those two things are equal. Even though when you look at the very beginning with the 3 different pieces, they look nothing alike. But they are in fact exactly the same. Or in other words, the secant equals the secant. You guys try letter B. Okay, so in this next example, if we go with the same stuff that we were talking about earlier, change the sines and cosines. Cotangent is actually cosine over sine. Sine is just sine, but I'm going to write it down as sine over 1. And cosine is just cosine, so I'm going to write that down as... Did I write down t in all these?
Yeah.
What a moron. Whatever. It's supposed to be alpha, actually. Sorry. Use a lot of different variables, so. And in this one, just like the previous one, you notice that something reduces, the signs reduce. And in the final answer, you end up with that the cosine of alpha equals the cosine of alpha. And again, all you're doing is proving that this is a true statement, even though in the beginning it doesn't look true. No big deal.
Here, boy.
We go.
Oh, we go.
All right, guys, last one. So according to the safety sticker on a 20-foot ladder, the distance from the bottom has to be at least, or it has to be 25% of the ladder. If the ladder is in this position, what's the acute angle between the bottom of the ladder and the ground, and how high up the wall will the ladder reach? This really doesn't have a ton to do with what we've been talking about, but it's about trigonometry and right triangle trig, so that's why they throw it in here, so that you don't forget. So I'm just going to draw a picture. first of all, here's a wall, and here's a ladder. Oh my goodness. And look, here's the ground. Crazy. It's a right triangle. So this is the ladder. It's in orange. And the wall is in black. And the ground is in blue. And I know that they tell me that the ladder never changes. It's 20 feet. And what I know is that the distance from the bottom of the ladder to the base, what is that stuff talking about?
The ground.
The ground. So I know that the distance from the bottom of the ladder to the base of the wall is that blue stuff. And it has to be 25% of the length of the ladder. So the way I find that is I just go with 25%, 0.25 times 20, and I get 5?
Yeah.
Okay, thank you. 5. So here's 5. Now I could use a Pythagorean theorem, right?
Yes.
To find the wall length. So go do that. Pythagorean theorem me.
Oh, you.
Dirty dog.
Wolf. That's square root of 375.
Okay, the square root of 375. I like that. Can you give it to me to the nearest 2 decimal places so I can just...
19.36.
Thank you. 19.36 feet. So that was, I believe, B. How high up is that ladder? 19.36 feet. And if I wanted to find the angle that I'm making with the ground, they're talking about this thing right here, that theta. So there are lots of ways to figure this out, especially since I have all 3 sides. But let's say I'm talking about the ladder that I know for sure that they gave me. And because 25%, I know the 5 on the ground has to be there. And I have the angle that I'm looking for, the adjacent side and the hypotenuse. Adjacent and hypotenuse means I'm talking about cosine. So the cosine of my angle is the adjacent side over the hypotenuse. And whenever you're looking for an angle, I don't want the cosine of that angle, I want the angle. So you have to undo that stuff. So to undo cosine, you have to inverse cosine it, or arc cosine. So when you look for that, that means you're actually going theta equals the cosine inverse of whatever the crap was that you talked about originally. So the stuff that you see here is the stuff that goes in there. And then you just type that into your calculator and out pops a number. Go to the nearest hundredth again. Thank you. 75.52 degrees. Please, when you give angle measurements, if not specified, give them to me in degrees to the nearest tenth, unless otherwise, or 100, excuse me, unless otherwise instructed.